Hey guys, it's Miss Gertson. So we're gonna start on your do first. And this do first, I'm gonna walk you through almost all of it because what I'm gonna do is show you how I would work through problems if this was the benchmark next week. Okay, so I want you to be writing what I'm writing and seeing how I solve things and figure things out. Okay, so if you were given this next week on the benchmark, it might look really overwhelming. But you want to remember that our goal is always to get a variable alone. So we're trying to get x alone. We know that we usually work in reverse order of PEMDAS, but we often have to distribute first. I have variables on both sides, but if I look right here, there is a negative on the outside of this parentheses. We do not distribute the negative 5x. What's on the outside is the negative. Okay, so you can think of it as KC. So we're keeping negative 5x. We're going to make this positive, this 6 is negative, and this 2x is negative. All right, make sure you've done that. Now we're going to rewrite it. We have negative 5x plus negative 6 plus negative 2x is greater than or equal to 24 minus x. You can see I did the same thing over here. I showed it as distribution. Negative times the x is negative x. Negative times the 2 is negative 2. Okay, now our goal is to get x's on one side, but we currently have two x's over here. We need to combine them. So we have negative 5x and negative 2x. If I were to type that in my calculator, negative 5 plus negative 2, we get negative 7x. So those are combined. Plus negative 6 is greater than or equal to 24 minus, I'm going to write 1x instead of just x. Okay, keep your river going. Now, as soon as I see variables on both sides, I want to make sure they're all on one side. So I want to get rid of this negative 1x. So this is where I'm in addition and subtraction. To get rid of negative 1x, I put positive 1x. Okay, negative 7x plus 1x will give me negative 6x. Now we have plus negative 6 equals 24. It's not equals to. Ms. Gertson made a mistake. It's greater than or equal to. Remember, it's an inequality. Now, my x is almost alone, but I'm still on addition and subtraction. I need to get rid of negative 6, so I need to make it a 0. So I'm going to do positive 6 on both sides. I get negative 6x is greater than or equal to 30. Okay, one more step. These are being multiplied. To undo that, I need to divide. And you need to remember, you divide by what you see. I'm going to divide by negative 6 because my goal is to get positive 1x. And here's the special thing about inequalities. See how I flipped right here? If you divide or multiply by a negative, you have to flip the sign. So I'm going to remind myself, flip. This flips the other way. 30 divided by negative 6 is negative 5. So my solution is x is less than or equal to negative 5. Notice it forms the L. That's how I know it's less than. Okay, make sure you have that all copied down. Okay, number 10. Which graph determines a functional relationship between the independent and dependent quantities? Blah, blah, blah. Just notice it's asking which one is functional, which means which one is a function. This was when we learned each function, each x value matches one y value. Each x value matches one y value, and the way we can tell that with graphs is the vertical line test. So we can draw lines through a graph, and as long as we only touch the shape once, it's a function. But notice, when we are drawing these lines, we are touching the shape twice each time we draw a line. So this one is not a function. Now I'm going to go here, and I'm going to try to draw it with something darker so that you can see. Let's see here. Or this highlighter will work. If I draw my lines, notice when I draw one line, I end up touching it at 2 points. That is not okay, so this is not a function. Okay, now I'm going to go over here. When I draw my lines, every time I draw a vertical line, I only touch the function once on each line. That means this is a function, so the answer is G. I want to show you on J. The same thing happens from before. We are touching it at 2 points, so it is not a function. Okay, go ahead and flip it over. Okay, these can be overwhelming. It's a word problem. I want you to go down to this. It says, if the data is graphed, the total cost is on the horizontal axis. The horizontal axis is this axis, which is the X. So this is X. And the sales tax is on the vertical axis, Y. You don't have to worry about that, guys. Any table set up like this, X is always first and Y is always second. So now notice it's asking about the slope. Okay, as soon as you see slope, on your benchmark there will be a formula that you can go to and you will see the formula for slope. Okay, remember the Y's are on top, the X's are on bottom. We have to subtract. So if this is my Y value, I'm going to subtract 0.75 minus 0.60. This is my X value. I'm going to subtract 10 minus 8. So let's go ahead and find out. 0.75 minus 0.6 is 0.15. And then 10 minus 8 is 2. And now we have to divide. 0.15 divided by 2. I get 0.075. So all of these have 7s and 5s, but notice that this is 0.075. So it's like, how do we decide which one is the slope? It wants to know what it represents. Well, the slope is Y over X, so it's sales tax is on top. It's sales tax over total cost. So it's how much tax per cost. Tax per cost. Is that the same thing as total cost? No. Percent sales tax rate. I'm not sure, but I know that rate sounds like slope, rate of change. 7.5 charge for sales tax. 750 charge. Well, this is actually 0.075 per one, so that's not $7.50. Sales tax rate of 75 cents for every dollar spent. No, it's 0.075 for every dollar. So the answer is actually B, because a percent and a decimal, remember when you have a decimal you turn it into percent, you just move the decimal twice. If you didn't know that, I don't want you to freak out. I'm just walking you through the problem. If you didn't know it, just watch what I'm doing.